The inspector's concern regarding the AC compressor wiring is valid. The AC compressor's rated load current or RLC should not exceed 30 amps as per National Electrical Code section 440.22. Using a 50 amp breaker on a number 10 wire could allow for a higher current flow than the wire is rated for, which could lead to overheating and a potential fire hazard. The electrician's argument is partially correct, but may be misinterpreting some National Electrical Code requirements. National Electrical Code section 310.16 does allow up to 40 amps on a number 10 wire, but this is generally only for continuous loads. An AC compressor is not typically considered a continuous load and can draw higher currents for short periods such as during startup or periods of high demand. National Electrical Code section 440.22 does allow for a breaker to be sized up to 225% of the rated load current of the equipment, such as AC compressors. However, it's essential to understand the implications of this rule. The actual current draw of an AC compressor varies depending on its size and capacity. For a 2,800 square foot home, the compressor's RLC could easily exceed 30 amps, especially during periods of high demand or startup. For a safe installation, the wire size and breaker should be sized appropriately for the actual RLC of the AC compressor. If the RLC of the compressor is less than or equal to 30 amps, a number 10 wire with a 30 amp breaker is generally acceptable. However, if the RLC of the compressor is greater than 30 amps, a number 8 wire with a 40 amp breaker is typically recommended. Using a number 10 wire with a 50 amp breaker on an AC compressor is generally not considered safe, based on the information provided in general National Electrical Code practices. It is recommended to have the system rewired with the appropriate wire size and breaker for the compressor's rated load current. It's important to consult the AC compressor's nameplate for its RLC. This value is crucial for determining the correct wire size and breaker. Also consider the minimum circuit ampacity, or McCaw, which is the minimum required ampacity for the circuit conductors. This value may be higher than the RLC and should be used for wire sizing. The maximum overcurrent protection, or MOP, indicates the maximum breaker size allowed for the equipment. This value must be considered when selecting the breaker. Now let's discuss some key concepts in more detail. Firstly, conductor ampacity. The ampacity of a conductor is its current carrying capacity, expressed in amps. It is the maximum current that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. National Electrical Code section 310.16 provides ampacity ratings for various conductor sizes and insulation types, based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. The ampacity of a conductor is affected by several factors, including its size, insulation type, the number of conductors in a raceway or cable, and the ambient temperature. When multiple current-carrying conductors are installed in a raceway or cable, the ampacity of each conductor must be derated to account for the increased heat generated. National Electrical Code section 310.15 provides adjustment factors for conductor ampacity based on the number of current-carrying conductors in a raceway or cable. High ambient temperatures can also reduce the ampacity of a conductor. National Electrical Code section 310.15 provides correction factors for conductor ampacity based on ambient temperature. Secondly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits and equipment from overloads and short circuits. An overload is a condition in which the current in a circuit exceeds the ampacity of the conductors or the rating of the equipment. A short circuit is an unintentional connection between two or more conductors that have a difference in potential. Overcurrent protection devices are designed to interrupt the flow of current in a circuit when an overload or short circuit occurs. Circuit breakers are resettable overcurrent protection devices that trip open when an overcurrent occurs. Fuses are non-resettable overcurrent protection devices that melt and open the circuit when an overcurrent occurs. The size of the overcurrent protection device must be selected to protect the conductors and equipment in the circuit. The overcurrent protection device should not be larger than the ampacity of the conductors it is protecting unless specifically permitted by the National Electrical Code. National Electrical Code Section 240.4 provides requirements for overcurrent protection of conductors. Thirdly, motor circuit protection. Motor circuits have specific overcurrent protection requirements due to the inrush current that motors draw during startup. The inrush current can be several times the motor's full load current. National Electrical Code Section 430 provides detailed requirements for motor circuit protection, including the sizing of conductors, overcurrent protection devices, and motor controllers. Motor circuit conductors must have an ampacity of at least 125% of the motor's full load current. The motor's overcurrent protection device must be sized to protect the motor from overload and short circuit, while also allowing the motor to start and run without tripping. The National Electrical Code permits the use of inverse time circuit breakers, which allow for a short duration overload without tripping. However, the maximum size of the inverse time circuit breaker is limited to a percentage of the motor's full load current, as specified in National Electrical Code Section 430.52. Fourthly, air conditioning equipment. Air conditioning equipment is considered motor-driven equipment and is subject to the requirements of National Electrical Code Section 440. National Electrical Code Section 440 provides specific requirements for the sizing of conductors and overcurrent protection devices for air conditioning equipment. The conductors supplying air conditioning equipment must have an ampacity of at least 125% of the compressor's rated load current or the branch circuit selection current, whichever is greater. The overcurrent protection device for air conditioning equipment must be sized to protect the conductors and equipment from overload and short circuit, while also allowing the equipment to start and run without tripping. The National Electrical Code permits the use of inverse time circuit breakers for air conditioning equipment, with the maximum size limited to a percentage of the compressor's rated load current or the branch circuit selection current, as specified in National Electrical Code Section 440.22. It's important to consider the nameplate information on the air conditioning equipment when sizing conductors and overcurrent protection devices. The nameplate will typically include the compressor's rated load current, the branch circuit selection current, and the minimum circuit ampacity. Now let's circle back to the original issue. The electrician is citing National Electrical Code Section 440.22, which allows for an overcurrent protective device up to 175% of the rated load current, and in some cases up to 225%. This allowance is to accommodate the motor's inrush current during startup. However, this doesn't mean that you can simply put a 50 amp breaker on a number 10 wire. The wire still needs to be protected. The inspector is concerned that the number 10 wire is not adequately protected by a 50 amp breaker, and they are correct to be concerned. Number 10 copper wire, with typical insulation such as THHN, is generally rated for 30 amps when used in a residential application, according to National Electrical Code Table 310.16, assuming the 60°C column is used, which is common for terminations. While the 75°C column may allow for a higher ampacity, the termination points at the breaker and equipment often limit the use to the 60°C ampacity. Even if you use the 75°C column, which allows for 35 amps, a 50 amp breaker exceeds that ampacity. While National Electrical Code Section 240.4b does allow for the next standard overcurrent device to be used in some situations, this is typically for situations where the conductor ampacity doesn't exactly match a standard breaker size, and it's usually a single step up. Going from 30 amps to 50 amps is a significant jump and not typically permitted. Here is a breakdown of why the electrician's logic is flawed. The electrician is calculating 175% of the wire's ampacity, not the compressor's rated load current. The 175% rule applies to the overcurrent device, not the wire itself. The wire must be sized to handle the load current, and the overcurrent device protects the wire from overloads and short circuits. The electrician is relying on the exception that allows for a larger breaker to accommodate the motor's inrush current. However, this exception doesn't override the fundamental requirement that the wire must be protected. In this case, a 50 amp breaker on a number 10 wire is not providing adequate protection. Here's what you should do. Firstly, obtain the specifications for the AC compressor. You need to know the rated load current, the minimum circuit ampacity, and the maximum overcurrent protection. This information will be on the compressor's nameplate. Secondly, consult National Electrical Code Table 310.16 to determine the appropriate wire size for the compressor's load current, taking into account the dirting factors if necessary. Thirdly, select an overcurrent device that is sized according to National Electrical Code section 440.22, but does not exceed the ampacity of the wire. Fourthly, if the compressor's rated load current is greater than 30 amps, you will need to upgrade the wire to number 8, which is typically rated for 40 or 45 amps, depending on the insulation type and temperature rating. You will also need to install a 40 amp breaker. If the compressor's rated load current is less than or equal to 30 amps, you can use number 10 wire with a 30 amp breaker. However, it's always a good idea to consult with a qualified electrician to ensure that the installation is safe and code compliant. It's important to note that local codes may be more stringent than the National Electrical Code, so you should always check with your local building department to ensure that you are following the correct requirements. Finally, consider the long-term implications of using a smaller wire size and a larger breaker. While it may seem like a cost-effective solution in the short term, it could lead to problems down the road, such as overheating, voltage drop, and even a fire. It's always best to err on the side of safety and use the appropriate wire size and breaker for the application. In conclusion, while the electrician's argument may seem technically correct on the surface, it's based on a misinterpretation of the National Electrical Code requirements. A 50 amp breaker on a number 10 wire is generally not considered safe for an AC compressor, and it's recommended to have the system rewired with the appropriate wire size and breaker.